right, so this is the second video on graphing rational functions with slant asymptotes, okay? Remember, we have a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. And you can tell by looking at this function, the numerator's degree is 3, the denominator's degree is 2, and obviously that's 1 more, okay? So, as always, first thing we want to do is to factor both the numerator and denominator, okay? That allows us to find the zeros, the x-intercept, y-intercept sometimes when necessary, and the vertical asymptotes, all right? There is no removable discontinuity here because none of these factors cancel out, okay? So we're going to have 2 vertical asymptotes, one at -2 and one at +2, okay? There's not a horizontal asymptote because the degree of the numerator is greater than the degree of the denominator, okay? But we will have a slant asymptote, okay? The x-intercepts, we want to look at the numerator there. We've got an x-intercept of 0. Now notice that 0 occurs twice, okay? And if you think back to our polynomial functions, if we have a multiplicity that's even, the graph is going to bounce off of that 0, okay? So whichever way we're coming up to this 0 or down to that 0, once we hit that, we're going to bounce back in that same direction, okay? The other x-intercept is -1, all right? It has a multiplicity of 1, so we're going to cross the axis there at -1, all right? Because the x-intercept is at x equals 0, the y-intercept is also going to be right there at the origin. We can't have another y-intercept. It has to be at the origin, okay? Now, because the denominator is not a linear piece down here, this is x squared, this would be quadratic, I can't use synthetic division, okay? So I'm going to have to use long division to find the slant asymptote. So let's do that now. All right, so we're going to use long division here to find the slant asymptote. So the numerator was x cubed plus x squared. Remember, we need the placeholders 0x and 0. The denominator was just x squared minus 4, so we've got to have the placeholder there 0x, okay? So x cubed divided by x squared is going to be 1x. So that's going to go over x to the first there. So we want to multiply. That gives me x cubed plus 0x squared minus 4x, okay? We're going to subtract, remember. All right, so x cubed minus x cubed is nothing. X squared minus 0x squared is going to be 1x squared. 0x minus a -4x is a positive 4x. And bring down the 0, okay? X squared divided by x squared is going to be a positive 1, okay? And that's going to give me x squared plus 0x minus 4, okay? I don't even need the remainder, so I'm not going to do any of this subtraction here. I just know that my slant asymptote is going to have the equation y equals x plus 1, okay? So let's go back to the document. Okay, so we found the slant asymptote to be the equation y equals x plus 1. And again, the remainder is irrelevant there. We just needed to find the quotient, okay? So now then, let's do the behavior of the graph as it approaches each of those 2 vertical asymptotes, okay? So I want to approach -2 from the left. So when I plug -3 into my function, I get -3.6, okay? Get a little bit closer to that vertical asymptote, -2. So I'm going to plug in -2.1, and I get -11.83, okay? So what that means is, as we approach -2 from the left, y is going to approach -infinity, okay? Now let's approach -2 from the right. So first I'm going to plug in -1. That gives me 0. We already know that's in one of the x-intercepts, so that one was easy to calculate, to fill in. Now let's plug in -1.9. We want to get right up next to that -2, and that gives me a positive 8.33. So you can see we're getting bigger there. So as we approach -2 from the left, the graph will be approaching positive infinity, okay? Now our second vertical asymptote is at x equals 2. So let's approach 2 from the left. So I'm going to plug in 1, and I get -2/3, okay? Let's get a little closer to that 2. Let's plug in 1.9. Again, we're coming from the left, and that is going to equal -26.84. So as we approach 2 from the left, the graph will be approaching -infinity. All right. Now we want to come from the right of that 2, so let's plug in 3 first, and you get 7.2 when you do that. Now we want to plug in 2.1, and we get 33.34, okay? So as we're coming towards that vertical asymptote from the right, y is going to approach positive infinity, okay? Next thing I want to do, I know I've got a slant asymptote, so I need to plug in some values that are going to be on my grid to make sure I know what's going to happen as we go to the extreme left and the extreme right, okay? So if I plug in -9, I didn't plug in -10 here for a reason. When I plug in -9, I get -8.42, okay? So I can plot that point a little bit later on. Let's plug in +9. When I do that, I'm going to get 10.52. So those are a couple ordered pairs that I can graph that will make it very clear what's happening as we approach -infinity to the left and +infinity to the right, okay? So let's go ahead and graph that function, take a look at this one, and we'll be done. Okay, so we're going to graph this function. The function was r of x equals x cubed plus x squared over x squared minus 4, okay? We'd already found the vertical asymptotes at -2 and 2. We used long division to find the slant asymptote at y equals x plus 1, okay? Now then, we want to plot our x-intercepts. There was an x-intercept at 0, okay? And there was an x-intercept at -1. So we had an x-intercept here and an x-intercept there. Remember that x-intercept at the origin also acts as the y-intercept, okay? So using our table of values, we had a point at -9 and then down almost 8.5. 1, 2, 3, 4, 5, 6, 7, 8.5 here. Okay. We had a point at -3, 1, 2, 3, and then down 3.6. So down 1, 2, 3.5. Okay. And then we had another point at -2.1 and then down here. Okay, so we can already see what this piece is going to look like, okay? So remember, the end behavior here is going to approach that slant asymptote, and we knew coming at -2 from the left, we were approaching -infinity. So that's what that piece of the graph is going to look like, okay? Now, this middle portion here, the slant asymptote has nothing to do with that, okay? When we came at -2 from the right side, we were going towards +infinity, okay? Not a very good line there, but we're going to go with it. Remember, this x-intercept of -1 had an odd multiplicity. So we're actually going to dive down here below the x-axis just a little bit. Okay. We also had a point at 1, -2/3 that was in our table of values. Okay. So remember, when we get back to this x-intercept here at the origin, we're going to bounce off of that. It had a multiplicity of 2, so we're going to go back down. Okay. And we also know from what we worked out, when we approached 2 from the left, we were going to -infinity, okay? So that's part of the graph is going to go down like that, okay? So again, this little piece right here is just below the x-axis. Not much, okay? But it's below there because we had to cross at -1 because it had an odd multiplicity, all right? Now, on the right third of this graph here, we had some points we could plot. We had 3, 7.2, so 1, 2, 3, 4, 5, 6, 7. So about right there. Let me erase this point. Okay. All right. And we also had another point at 9, 10.52. So 9 up here at about 10.5. Okay. So we know as we're coming through here, the graph is going to approach that slant asymptote as we go up and to the right. And we also learned when we were approaching this vertical asymptote from the left, we were going up to +infinity. So that's what that piece is going to look like, okay? So that's the graph of this rational function with 2 vertical asymptotes and 1 slant asymptote.